Beyond our night sky lies a universe of almost unimaginable scale, an ocean of space filled with billions of stars and countless galaxies. Our Milky Way is just one among them, but among all these stellar islands, one stands out as our most imposing neighbor. A galaxy so vast it redefines the very meaning of distance. Andromeda, a colossal spiral of stars, dust, and gas, located more than 2 million light-years from Earth. The light we see today began its journey long before humanity ever walked the planet. When we observe it, we are not looking at the present. We are looking into the past. Andromeda is larger than the Milky Way. It contains hundreds of billions of stars, and it is moving. It is approaching our galaxy, slowly, inevitably, on a path that, billions of years from now, will forever change the night sky. This is a journey through space. This is the journey from Earth to Andromeda. Around us, countless stars blaze, each a potential sun to its own planetary system. The Milky Way itself spans an astonishing 100,000 light-years from one edge to the other. Our own solar system resides in one of its outer spiral arms, a quiet corner within this vast stellar metropolis. The majority of these stars are red dwarfs, small, cool, and incredibly long-lived. They constitute approximately 70% of all stars in our galaxy, yet their faint luminosity renders them invisible to the naked eye from Earth. Every star we pass represents an entire solar system, potentially harboring planets, moons, and perhaps even life we may never discover. The distances between these stellar neighbors are so immense that even at the speed of light, years would pass before reaching the closest one. As our simulated journey continues toward Andromeda, a profound transformation begins. The stellar density gradually diminishes. Fewer and fewer points of light punctuate the deepening cosmic darkness. We are approaching the very edge of our galaxy, poised to enter the profound emptiness of intergalactic space, a realm where matter is spread incredibly thin. And there it is, our home galaxy, the Milky Way, now seen from an external vantage point. A majestic spiral containing over 400 billion stars, stretching across 100,000 light-years. Every human who has ever lived, every story ever told, every civilization that ever existed, all of it unfolded on one tiny planet, orbiting one ordinary star. That star is now an indistinguishable point, lost among the 400 billion others in this grand cosmic structure. Yet look around us. Hundreds of galaxies surround us in every direction, scattered like cosmic jewels through the profound darkness of intergalactic space. Each one contains billions or even trillions of stars. We are situated within what astronomers call the local group, a gravitationally bound collection of over 80 galaxies. The largest and most dominant member of this group lies directly ahead. Andromeda is drawing closer now. From Earth, it appears as a faint, ethereal smudge, barely discernible to the naked eye. But up close, its scale is truly monumental. This galaxy is, in fact, larger than our own Milky Way, extending over 200,000 light-years across. It contains an estimated 1 trillion stars, more than double the number found in our home galaxy. In approximately 4 billion years, Andromeda and the Milky Way are destined to collide. These two colossal galaxies will merge over hundreds of millions of years, ultimately forming one colossal elliptical galaxy. For the vast majority of human history, the true nature of this celestial object remained a profound mystery. Ancient astronomers observed it as a small fuzzy patch in the night sky. Some described it as a little cloud, while others speculated it might be a distant star enveloped by glowing gas. In the 18th century, astronomers cataloged it as a nebula, mistakenly believing it to be merely another object residing within our own Milky Way. For over a century, the prevailing scientific consensus held that the Milky Way constituted the entirety of the universe, and everything observable in the night sky existed within its boundaries. However, in 1923, an astronomer named Edwin Hubble fundamentally reshaped our understanding of the cosmos. He meticulously measured the distance to this enigmatic nebula and made a groundbreaking discovery. It was over 1 million light-years away, far beyond the perceived edges of our galaxy. We now know the true distance is closer to 2.5 million light-years. This object was not merely a nebula within our galaxy. It was an entirely separate galaxy. In a single monumental discovery, the known universe expanded from a solitary galaxy to an unimaginable multitude of billions. This revelation profoundly altered humanity's perception of its place in the cosmos, transforming our understanding of cosmic scale. Now, we are entering Andromeda itself. Around us, we observe some of the oldest stars within this magnificent galaxy. These ancient red and yellow suns ignited over 10 billion years ago, bearing witness to the early epochs of galactic formation. Andromeda is roughly the same age as our Milky Way, both having formed approximately 13 billion years ago. This galaxy is a stellar behemoth, containing an estimated 1 trillion stars, more than double the population of our home galaxy. If one could perceive every star in Andromeda from Earth, its apparent size would span 6 times the width of the full moon in our night sky. Yet, Andromeda does not journey alone through the cosmos. It is accompanied by dozens of smaller satellite galaxies, held captive in orbit by its immense gravitational pull. The two brightest of these companions, M32 and M110, are even visible through small telescopes from Earth, offering a glimpse into Andromeda's gravitational dominion. We are now traveling through one of Andromeda's majestic spiral arms, regions teeming with vibrant, young blue stars and vast, intricate clouds of gas and dust. These nebulae are stellar nurseries, where new stars are continuously being born, illuminating the galactic arm with their brilliant, youthful light. The central region of this galaxy presents a stark contrast. Unlike the dynamic spiral arms, the core is densely packed with older, cooler stars, which collectively impart a distinct yellowish glow to this ancient heart. And at the very nucleus of Andromeda, as is common in most large galaxies, resides a supermassive black hole. This particular behemoth possesses a mass approximately 140 million times that of our Sun, a gravitational anchor for the entire galaxy. But Andromeda's story is far from complete. At this very moment, this colossal galaxy is hurtling toward our Milky Way at an astonishing speed of approximately 110 kilometers per second. In roughly 4 billion years, the two galaxies are destined to collide. This will not be a violent, destructive crash in the conventional sense. The stars within each galaxy are separated by such immense distances that most will simply pass by each other, like ships in a vast cosmic ocean. However, the powerful gravitational forces exerted by each galaxy will profoundly reshape both structures. Over hundreds of millions of years, these gravitational tides will twist and distort the galaxies, tearing apart their delicate spiral forms. Eventually, the Milky Way and Andromeda will merge into a single, colossal elliptical galaxy. Some astronomers have already bestowed upon this future cosmic entity a name: Milkomeda. For now, Andromeda remains our closest large galactic neighbor, a trillion stars bound together by the invisible hand of gravity, slowly but inexorably moving through the vastness of space. It journeys toward an inevitable merger with our own galaxy, an event billions of years in the future, promising a transformed night sky for any future inhabitants of our solar system.